That should be working now. Oh, OBS failing me. Let me know if you can hear me now. Because I've been going on, friends. Oh my god, I've been going on for a while here. Alright, so I'm a little bit behind on the stream. If somebody could let me know if they could hear me now, that would be great. Okay, Sandy, what's up? Or Isovector if you prefer. Okay, I was yammering on there for a while. So I apologized for last week's stream. It wasn't that great. I was super tired. I really didn't want to do the stream. I had a stressful day. But sometimes, discipline, you just got to show up. And this week is going to be a lot better because while last week I tried fumbling around, getting buffering going from our socket and trying to figure out why we're only getting a single character at a time off our receive call, I found that when I compile it on a Unix-like operating system, it does work as I had expected, so it wasn't our code. My code, fine. It turns out that when you take this program here, and you compile it under Windows, and you run it under Windows natively, you'll get the behavior we've been seeing on the stream, which is it echoing one character at a time when you call receive here. It's not getting a full, even buffer line width of 1024 characters. We're just getting a single character at a time, but it's not us. So Isovector wants to know, what are we making? We're making a key value data store from scratch in Haskell. It's kind of like a little learning project to kick the tires, see how things are going. Right, so networking under Windows. Not that great at the moment. It might be a bug in the network library. It could be a bug in GHC's runtime. So if you haven't heard about the functional programming Slack, you should probably get on there. I hang out on there and on the Zulip functional programming chats server. And if you ever want to talk about Haskell and like shoot the stuff, talk about Rosby, our little database server, talk about your project, I'd love to hear about it. I love programming. I love talking about programming. But anyways, somebody on the FP chat there told me that about some work in Windows. There's going to be like a new GHC IO subsystem. It's going to work better with the Windows API. So for now, I'm going to like skip past the sockets. I'm going to get a WSL2 environment set up so I can run this under Linux for now. We'll just target Linux. I don't have that going 100% yet. So I'll probably have to rebuild GHC IDE under it and everything else if the file, I don't know. It's gonna be messy. It's not quite done yet. So today we're gonna move on to the parser and doing parsing. So if you're super experienced Haskell programmer and you're on the stream, welcome. Thanks for hanging out. If anybody is kind of newer and is asking questions and needs a little bit of help, feel free to pipe in and offer some of that help. So today we're just going to skip right to parsing. We might not get it hooked up to the server because again, WSL2, Linux issues, development environment stuff. Gotta figure that out. Let's get to the code. Okay, I'm going to start talking about protocols and serialization formats and parsing and stuff like that. I'm going to start a new file here. Don't know what to call it yet. Parser? Seems like a good enough name for me. Sure, go ahead and create it. Okay, so we're probably going to use... So last stream I also discussed about like how are we going to handle the protocol for this project, right? Like how I've had some ideas, maybe we could use HTTP. That's pretty straightforward. Nobody would really have to write a client because it's just plain HTTP, and every language on the planet pretty much has an HTTP client library by now. If you don't, you're probably just starting your language, and you should write one very soon. However, I thought maybe that might be a little bit heavy-handed. I'm not sure that we want to run like a whole entire web server in Rosby. And that's basically because, well, we wouldn't be using very much of it. And I feel kind of bad having like such a large dependency bring down our compile times and add all this extra surface to our program, and we're not really taking advantage of it. But fortunately, writing parsers in Haskell is like kind of like easy mode Haskell. I don't know if you've done it yet, but if you haven't, you should, because it's fun. And it's super easy. We're going to use a little library called attoparsec, which I'm going to go ahead and add here. We got byte string, that's going to be useful. Attoparsec. That's going to be our parsing library. It's nice and fast. It has good support for byte strings, which is what we're going to be parsing. And I think we might end up needing a couple more. I think we might need some libraries for dealing with word 8 stuff. So when you're parsing byte strings, you don't get like individual characters like you would when you're parsing a string or text from those types. You get like really low, you just get like literally the platform's car size, which is usually like an 8-byte character. Sorry, hackage, and we're going to search for word 8. There's a nice little library that has some kind of helper functions for constructing values of car 8 and word 8. So we're going to add that as well. It's a pretty small library, so I don't feel so bad taking that one on. That's good. Okay. So attoparsec is our other library, and that's going to be, we're going to need might need the documentation for that one up. Byte string. And there we go. Data attoparsec.bytestring. Cool. It would help if I knew what I was doing and knew how to type. I might need this type. Get rid of it if we don't end up using it, but I think this one needs to be imported qualified as well. I think it does have a few names that overlap with Prelude. So I'll name that a P for parser, B for byte string. That should be good enough. Yeah, my video isn't working. We had some pretty nasty, well, basically the bad day from last week was hardware failure. Started off with my phone dying, which I was using the camera from that to do the stream. Oh man, it's been a bad week for hardware. Phone died, laptop died. Just the other day, my kids destroyed the TV. So when it rains, it pours, folks. It's no good. But fortunately, Haskell's still here, and I fixed that issue. I figured out what was wrong with the networking. So, all right. Hopefully, I've adjusted the levels. Hopefully, you can hear me a little bit better. I promise video will come back at some point. My backup plan, some friends are going to lend me their phones, and I'm going to just take over those and get video back for the next week's stream. Okay. Right, so parsers are pretty cool. Parser combinators, that's what like data attoparsec is kind of built on, this idea of parser combinators. I won't go into like a tutorial on it, but I'll give you the high level idea. We're going to create like, you can think of it like this. It's like a new type that has like say a run parser kind of function. It's going to take some byte string and it's going to return a parser with that A in it and maybe some more data to parse. Okay, and so we write our functions in this type, and that lets us kind of like consume out like a bit of this, the butt of the byte string, get some data out, and then leave some more byte string to possibly consume with other parser functions, which is pretty straightforward, I hope. But the combinator part is where it's really powerful, because when we have this kind of structure here, we can write a bunch of functions that combine parsers together to get more complicated parsers. And when I first saw this, I thought it was kind of cool. Parser combinators are pretty awesome. So we're going to write one today on AutoParsec for our protocol. And so thinking about our protocol a little bit, I was kind of wondering, like, if we're not going to use HTTP, because it would be kind of nice to be able to use HTTP. It's got chunking kind of built in, so you can do streaming and things like that. How are we going to do that with Haskell? It turns out it's hopefully not going. It's going to be pretty straightforward, possibly due to the RTS and the runtime and stuff. So that will be pretty straightforward. But our protocol is going to have like the idea. The two major operations we're going to have is like request and response, right? And the client that's connected to our database is going to send us some data on our socket for us to consume. And the server's job is to like parse that data, figure out what the client intended to do. If they were trying to do the wrong thing or whatever, don't do that, but do the right thing. And then we send a response back. And there's kind of like, I'm taking some inspiration a little bit from Redis here in the design of this protocol, I think, because it's got three things I really like, which is what we kind of started off with in our sort of design philosophy here for this application. We want like simple, as in easy to understand. You could squint at the code and read it and kind of grok it fairly simply and extend it yourself. And the Redis protocol is kind of built around a similar philosophy. It's meant to be human readable, easy to parse, and also fast. And I think it's going to be pretty amenable to an easy to write a parser and protocol for ourselves using the same kind of ideas. So the gist of it is that you've basically got like a handful of types in the Redis protocol. You've basically got like strings. Well, that's really fat. That's fine. Like integers. You've got arrays. And I think that's pretty much it. There might be like a couple different kinds of strings, but we'll just start off with that. Well, let's just look at the documentation page for it before I start like diagramming out the universe here and reinventing things, because it's pretty good. And we're going to kind of model this stuff off. Actually, let's just dig into it. Let's stop just chatting. So the idea is that basically we have a string like that would look like this. It would say like, okay, for an R and N, and then it would be like food and R and N. And this would be an example of the protocol sending a string. So the $sign indicates the type. This is a string. The number here is how many bytes to parse in this string. The r/r/n is kind of a convention often used in network programming, the carriage return and line feed. Then we have our 4 bytes, and then we end the string with another carriage return and line feed. An example of a bad string, an invalid one, so this is good. God, good. This is bad. All right, we have for, if we only give 3 bytes, that's no good. It's bad. Another bad one would be like 4 and then like only a /r and then something. Just, you're walking into the park there, bud. Go home, have a beer, chill out. I think in the Redis protocol, they have this because when we get to Arrays, there's no separator between values in the array, and they do something called pipelining. We might not need it, but pipelining would allow the client to string together a bunch of these in one go. So we're going to write the parser for strings for that, and we'll just get going. So I'm going to create the data types to represent these things. Well, let's just go through integers quickly. Integers start with a colon, and then it's just the number, like that. I think in the Redis protocol, they kind of allow like integer types, like boxed integers, so they'll take like any ungodly huge number. I'm not sure how practical that will be, but they only output 64-bit integers, I think. Bad. I don't know, few, that kind of stuff. And then arrays. So arrays are kind of a similar idea. They have a special type as well. That's indicated by the asterisk or star. That tells you how many elements are in the array. And then you just start parsing stuff in here. So $for a string. That would be good. We could do like a number. And maybe another number. Who knows? Let's get wild. All right, this would be a valid array. Similarly, you can imagine what the bad scenario would look like. So that's kind of the idea, and I'm gonna approach this is the serialization format for the line, like what's talking off the socket, and then from these kind of like little primitives, it's kind of like taking a lexing step. We parse into these, and then we would parse those inputs into commands for our database, like set key, delete key, and that kind of thing. So I'm going to go ahead and call, what do I call these, primitives, prims? And I like the idea of this design a little bit. Maybe you have better ideas. I'm going to put an array inside of an array. I don't see why not. Although it might not be valid input, but we could parse it and that would be fine. And we'll see why in a minute. So we're gonna parse these primitives, and that's just going to give us kind of like some basic data structures to work with. And then we're going to parse these primitives into the actual commands on the line. Was the idea anyway. I'll see how it goes from here. So let's go. Stir. It's going to have its size. Let's make that an int and a byte string. We're going to have a number. That's just going to be, I don't know, if we should go integer. We could go integer, and array, which is also going to have its size. And we'll just parse it for now as a list of prims. We might change that later on to be, seems like a good fit for a vector, but for now, it's okay. It's all good. We can refactor it later. Let's derive some basic instances. Which, if you can, you probably should. At least those. Okay, so that's our data structure for those things, and we're going to write some parsers for, I guess, for strings first. And what does that look like? Let's call it string parser. And it's just going to be a parser for prim. oh, it's, of course, I'm gonna just import that type. Yes. Thank you. Okay. All right. So when we're in our parser, the parser, I don't know if the hover over details from LSP here. Is it even working? I don't know. Oh, it says it's running. But this has an instance of monad, so we can be inside the monad here and use our sweet do notation to run different parsers. So the first thing we're gonna do is probably gonna match on that $sign so that we know we're in a string parser. That needs a car8, which I'm going to get from that word8 library. So I'm going to import that here. I think it's word8. Yeah. And that's going to be underscore asterisk. It's not in Scoop. Oh, do you not know that I have that yet? Oh, okay. Maybe it didn't automatically download the dependencies for us, so we should probably build the project. Oh, shoot! No, that's the WSL environment, which won't work. Data. There we are. The other one. Okay. That'll work once it's going. So we get the car8, the asterisk, and then we're gonna. What do we need to do next? We need to get the line separator. I think car8 has that as well. I think it's just CR. LF. And then we have, well, actually, no, wait. That's before that, we have a number. Take while. Take while takes a function that's like a Boolean that tells us just keep taking the next character off the stream until, as long as this is true. So let's write a little function called isDigit. We'll get the character. And this is handy when you need a table. I think it's 38 or greater than. Oh, it's like 48 to 50 something. 57. Let me just bring up my ASCII table just to remember what that is. It's been a while. Yeah, sure. This one looks good. Oh, it's got no background. That's even better. So yeah, digits here. Let's see. Yeah, so that's the car. 0 to 9. Yeah, 48 to 57. Okay, I wasn't off. Still got it. This isn't right though. And use a logical connective that is proper and fit. Okay, so we get the number. That's still going to be like a byte string of digits. Right? Yeah, I guess it's easier just to commit it to memory. It's only like, what, 127 characters, so whatever. But my brain is getting old. It doesn't always remember all that stuff. But somewhere locked in there apparently is the ASCII range for digits. So I'm still good. I'm still allowed to be a programmer. They haven't kicked me out yet. You can be too. Old programmers for life. Okay. Right. So this num is actually going to be a byte string. So I should probably do something about that because we really should stop. Like, I could just go with another thing to like read the next set of characters off here and then read those, but the bytes we read off here depend on this number here. And if we're writing a good parser, we're going to do something that Alexis King termed. I hope I got her name right this time. I hope I got it right last time. Alexis King termed, which is parse, don't validate. It's a good maxim. It comes from Langsec. That's also kind of why I like this protocol a little bit. It's pretty easy to parse, and also if you need to know how many bytes to parse, and we're going to stop parsing if we don't get the exact number we're looking for. So we need a way to turn that byte string into an actual int, and sometimes you need the Hoogles. I think I remember the library, but it's not like integer, but it's like integer and byte string. Yeah, data byte string.car8. Is that a separate library or is that in data byte string? It is in byte string. Okay, so let's just import that. We'll import a qualified. It's B8. Sure. Not sure if they're going to overlap, so case of B8. We're going to have two cases, so just num prime and nothing. Nothing case is easy, fail. String length must be an integer. How dare you send me something I cannot parse? Okay. And in the just case, we have num prime now, so we can continue parsing, and we've already consumed the character return in line feed. So we're going to use parsecs. I think it's take. Yeah, take. Take takes an integer, as you can see, and takes just that many bytes. And parses just that many. That's it. Which is exactly what we want. So, haha, take that. That's going to be our stir, so we'll keep a hold of that. And what else? We need this guy again. This guy again. And assuming we have everything now, we've consumed all of our input, we can now return a stir with num prime and the consumed string. Okay, let's just check that everything built. I got it wrong. Okay, it was me. Sorry, folks. Trying to go too fast. Slow down. Word 8, not car 8. Ugh. Let's grab you. That should be better. Okay. Car rate. Should. Let's see. Substring, no. Searching, no. Zipping and unzipping. Reading. Sorry, readint. Parsint. Okay. It's compiled. It works. Let's ship it. No. 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 Probably, we should probably write, maybe we should write some, start writing some tests for our code. We want to write some quick check tests for our parser. I was thinking of how we might do that, but let's just go ahead and give that an old college try, just to make sure that we're kind of on the right track, and then we'll look at writing tests. And then we'll probably start by writing a test for the next one. Pull up our old GHCI REPL. Okay, so we're going to need to import. I don't do a lot of work on GHCI, so you'll have to forgive me for my GHCI foo. Yeah, isovector, they totally are. I back up all my streams to YouTube on my YouTube channel. So if you want to watch later, you can't join, or you can't join in, you got to miss one, no problem. Just subscribe there. Hit that like button. Right. Where were we? We were gonna test this out on the REPL, right? So autoparsec. And I think we'll need that one, because it has some handy functions for packing strings to byte strings, so we can test this easily. Yeah. Cool. I really don't like that prompt. I gotta fix that. Gosh, look how huge that is. Okay, never mind though, that's okay. We're gonna basically test our function. We do that by running this parse. So running the parser is the next step once you have a parser. That gives us a result in autoparsec. And we can interpret the result into different easier to work with data types with like either or maybe, should the need arise. So we'll go ahead and do that. So we're gonna actually we're gonna either result. Let's just call it, let's actually make a little alias run parse. That's going to be either result composed with parse. Okay, it doesn't want to let me do that. Fine, whatever, it's okay. So let's just actually try to parse something first. So we have our string parser. Right, we should have that in scope. Cool. We're going to run it now. And we're going to just run it on a byte string. So we're going to run a pack. And if we just give it some garbage, what's it saying here? Parser's not in scope. Oh, parse, not parser. Okay, cool. So it failed because that was garbage input. All right. I don't terribly like the output of this, but that's okay. It's just the parser. So let's give it something good to eat. Let's give it our good example, food, or just good. Oh, for some reason that failed as well. Why did that fail? It's good to know. Let's go look. Let's have a peek. What did we do? Kind of expected that sort of work off the, oh, asterisk. That's why. That should be dollar for strings. I gotta bring my imports back. Ugh. There's a better way to do this. That'd be great. Tests, automated tests will be better. Of course, this is all messed up now. Failed on that. Yeah, I think I should. What are we doing here? Let's just check word 8. That's good. Match a specific type. Maybe we could just skip it. We don't really actually consume it and use it for anything. Okay. And dollar or okay. It's probably just rebel weirdness, typing things in wrong. That's what I expect. So what you can see now is the that good done thing there at the bottom. Here means that we ran the parser to completion. Oh, sorry, I drew over it. It's great. Here, done. There's no more remaining input. If there was, it would show up here. And then this is the data type we returned from our parser. All right. That's pretty good. Let's give it a couple more examples, just to make sure. So if we go 3, we should not get it. We should get a failure. It does. And if we put 5, that should also fail with not consuming all of the input. Oh no, that's right. If we miss a line feed, okay, that's good. If we give less than the input, So that's a partial. And if we try to use that other handy function, then maybe with the either result, either result, it'll give us a left, right? And the left will have the output string there, incomplete input, which is about what I expected there, because we didn't give enough bytes here. All right, this will speak, and then if we miss there. Okay. Cool. Cool. Ah, parsers are so much fun, aren't they? Okay, let's clean this up a little bit here. So I know, like, from our examples up here, if we're going to start working on the int one, we're going to be like having this r/n everywhere. We can see it in the array. We're going to be parsing that quite a bit. So let's create a parser for that. Line sep, call it. It doesn't do anything. It won't return anything. We'll just make it skip over it. Because this word 8 actually consumes a character and like could return it, but we're ignoring the input, which is so let's actually just skip over it. Which takes a word 8 to bool. So again, I think it's 10 and 13 that we need to skip over. That's 10 is the new line feed, and 13 I think is carriage return. So 13, C is equal to 13. Then C is equal to 10. And that's a parser. Cool. So we should be able to replace this one here with just line sep. Just line sep. So we should still get that. Get that. Cool. So it makes that a little cleaner. I think when we do get a failure, parsing that, we get incomplete input. Autoparsec has this nice little function that could help us in debugging if we get a little bit more complicated. And start building more complicated parsers. I don't know what to call it because it's they just define it as an operator. It's this one here, where you can just name the parser. And so if the parser fails, then it'll come up with that label so that when we're debugging things, we can see like where did it fail. So good handy little operator to use. I think I might have to import it here directly. Yeah, we'll just put it on our line sep parser there. And that will be, we'll just name it after the function. Okay, still got some lambdas here. So I'll pull those up. Is C control return. Is line feed. And now we can get rid of those. It'll be a little bit more readable. Cool, so that basically says, like, skip if it's a CR, skip if it's LF. Call it line sep. Handy. I like it. Okay. Now I can hopefully remember my muscle memory here. Get that back down to size. Okay, cool, cool, cool. Line separator, string parser. Let's move on. Let's do integers next. This one's going to be pretty straightforward. And then maybe we'll get to writing the test. I don't know. Usually I like to write the test first, but parsers are just so much fun. So we'll just call it in parser. That's going to turn a prim as well. Surprise, surprise. Cool. Int parser. We got to check. Do you have an asterisk? It's sorry, colon. Right? Yeah. This one's going to use take while, and we're going to use isDigit again. And we're basically just going to keep parsing integers, because I think we said, yeah, integers. So this could be an arbitrarily large integer, which might be bad for our protocol. Still on the fence about that one. Let's just get it going for now. All right, so now we're going to take that to be the parser take while and isDigit. And then we have line sep. That's it. That's all we need. That needs to be word 8. Okay, and we're going to read integer this time. Integer of none. We're going to fail. Failed to parse integer. I don't know if error messages should be like, I tried to do this thing. Past tense seems more natural. Yeah, like I tried to do this thing and I failed at it. So I'm gonna leave that there. That's fine. Anyways, random weird thoughts. Don't mind me. Okay, in the case where we do actually parse the integer, we can actually just return our our num, sorry, with num prime. That should be good enough. Let's reload. Let's try, not with the string parser anymore, but with int parser. Colon 1, 2, 3. Silliness. Colon 1, 2, 3. And this Windows really handles word wrapping really oddly in this terminal. Right. Incomplete input because we didn't put a line feed on. Cool. Numbers. Right. Scooby-Doo-Bop-a-Doo-Bop. Now here's why I think this might be a bad idea, and I might be on the wrong track. We don't want to parse arbitrarily large input. That's bad. Because then somebody could like overflow our server. All right, so parse, don't validate. You should really read this. It's a really good blog post, and it really summarizes a lot of things I kind of learned in my own programming journey by way of just reading people's parsers and reading about parsers and just collecting it from different places. But she sums it up really well. This page here. Parse, don't validate. So the idea is basically that we want to, this comes from langsec mostly. It just is a really good explanation of it. We really want like parsers that either parse correctly and give us the actual valid data type, or nothing at all. Like fail right away, which is why when string has the 4, when we're parsing it, we only parse the 4 bytes. Everything else is wrong. If you give us more content than that, we should totally, absolutely 100% not parse anything else. You lied to us, client. You lied. And there's security reasons attached to that, as well as just making sure your program doesn't crash when people send you unbounded, really large input or silly inputs, that kind of thing. So I guess the idea of it is you want to parse into a valid data structure. You don't want to be parsing something into a data structure and then validating it throughout your program. So that's what we're going to try and do here. With string parser and int parser, and then array parser. So what's really kind of interesting about this protocol, I think, is that the serialization format is slightly different from the way we're going to parse the actual like commands that the client sends. We just have to parse this very simple language, and then we're going to write a parser on top of it to parse into our actually domain specific language of our database. So int parser, all right, let's do the array parser. This is where we're going to start combining parsers, so it's going to be kind of cool. Array parser is going to return a prim as well. Okay. Yeah. So as we recall, arrays start with an asterisk. That's how we know we're going to be parsing an array. It tells us how many things to parse. And then as we're parsing the things, after this /r/n, then we just have to parse these things in the array. And these are all things we already know how to parse. We already have parsers for those. So this is where parser combinators become very convenient. All right, we have to fill in this type, an array of prims. So I think isovector brought up an interesting point there in the chat too. Could we have an array of arrays? Technically, I think with this version of the parser, that would be possible. Is that a good idea? Maybe not. I mean, they're all bounded, right? But basically what I think is like, could you just keep infinitely nesting arrays until we run out of memory on the server? That would be bad. So we might need to think about that too at some point and sort of refactor this parser not to parse arrays, just parse strings and ints when parsing an array. Which we can do actually. So let's get to it. Do parse this, please. colon, and this one's asterisk. Then we do our line separator. Cool. Oh no, we don't do our line separator yet. We do the num. We have to do another num. Take a while. Then we have the line separator. Now we have to also parse this as an integer as well. Right. And nothing. Array length must be integer. See, that's a command, right? I'm mixing up tenses here. Ugh, the writer in me is very disappointed. That's okay. I'm a programmer here. I don't need to be a writer. All right. So in the case where we do actually have a number, we only want to parse exactly that many things. So how are we going to do that? There is a combinator for that. Except it's not take. It's something else. It is count. Apply this action, this parser really, repeatedly, returning every result. That's the one we want. Count. Num prime. And then we have to give it a parser. What parser are we going to give it? Let's give it a stir parser or int parser. Try one of those, friends. Yeah, sure, clean that up later. Why is it complaining here? Yeah, oh, because we don't actually just want to return that. We want to take those, and then we're going to return our array with num prime and the parsed prims. Ta-da! Just control, let's just clean that up. Yeah, I don't like the way. Just import it. Oh, weird. Yeah, whatever. Yeah, okay, so we can't have an embedded array of arrays. We don't have to worry about that. What was I thinking? Getting ahead of myself. Yes, we can only parse flat arrays. We don't have arrays and arrays. Just strings or integers. Nothing else. We parse exactly none of them. Anything else or anything more is no good. And we return the array. The only thing, let's just test this out, because I think there is still kind of an issue with this. This dealing with this terrible terminal wrapping. Okay. So we do star, just one element, right? It's a string of 4 characters. And we have 4 bytes. That should be it. Of course, terrible word wrapping. 4. good. /r/n. Oh, I see. We have an extra character here. Right. Failed reading. Oh no. What have we done? Oh, we forgot to change the parser. Of course. Got a little ahead of ourselves. Array. Okay, that's better. That's what I expected. Array of 1. 1 string of length 4. Good. I like it. I like it a lot. Okay. If we try to add, say, another string. Say 3, length 3. Bad. What do we get? Just an array of 1. That's okay. But if we take off this other result and look at this, we still have input that's unconsumed. That's probably fine. We could probably leave that there for now. Maybe. We'll have to see. Okay, let's just make sure that if we try to add another element, say an integer. Oh wait, we're already over. Let's say that we're under. We're expecting 5 elements. Okay, we get a partial. And that's because we have incomplete input. We didn't give enough things to the to count. It's expecting more, so that's good. And if we give it some bad whatevers, see, there's our line sep. Error before that we were mentioning there. All right, so naming your parsers can sometimes help, especially if you have like little anonymous ones that you're throwing around. And you're using them in combinations with bigger parsers. So something to look out for. That's kind of nice. Failed reading a line separator. Okay, cool. That's kind of the basics of our parser for the most part. We could probably combine this together into one whole parser. And this one, array parser, string parser, or try one of those. This is bad input, I think. Yep. Yeah, we changed the input to 4. Oh. No, we got something in here that's no good. Oh, right, we're missing the /r/n on that. Right, so let's just do 2. A string 4. Oh, this is terrible. Anyways, we get the idea. It's cool. We don't need to do anything else here. that's our parsers on our prim parser. So why don't we go ahead now and maybe look, what else do we want to do today? Well, maybe we should probably commit this. I'll clean it up first. Add some module documentation, that kind of stuff. Okay, so let's start adding some Haddocks documentation. I feel pretty good about this, so let's go ahead and start documenting it. Strings are indexed by their length. Numbers are unboxed integers, or boxed integers. Oh. They just are. That's all they are. And arrays are indexed by their length and can contain stir and int. Yeah. Okay. That's good. Just get rid of that. I think everything else is pretty explanatory. What I like about this string parser and this int parser stuff, well, string parser really, the int parser is still kind of, and the array parser though, is that they take the size there and they won't continue parsing if we can't read the size and if we don't actually have the input. It's nice. It's nice. And this is super easy to parse. If we were trying to do something a little bit different, like, I don't know, if we were actually trying to parse the commands themselves right off the bat, that's kind of why I was thinking we might go this route with the serialization format, is that we could be like insert key, or put key, we might have delete key, right? And we'd have to like write a parser for each one. And we'd have to put all of this logic for writing string parsing and int parsing and put a lot of the semantics of our application into the serialization stuff and how it's serialized. That would make writing clients for our server kind of annoying. And we want to avoid that. We want the serialization protocol to be fairly simple. So the next step in this parser, instead of doing it this way and parsing into these commands where you have like put key, or you'd have like a key type, and then some byte string, and then a del key, which would be like just a key. We're going to basically take a prim, an array, from the array constructor, and we're going to parse that into a command. Right, so as we're consuming this list of prims, the first one will have to be some kind of string that we can match to the command. Right, and if it doesn't, stop parsing, so we can send an error back to the client. After the command, then the rest of the list, or the rest of the array, would be the parameters to construct the type. So key, a byte string in this case, some data, del key, and so on and so forth. And so we're kind of building up in layers here to our application from the socket. And then we can work at a higher level with these And then we'll probably dispatch off the command straight to figuring out how we can basically pipe this data straight into our data store from the handler. And I'm hoping that we can do this either with a stream or lazily, if Auto's parsec can handle that. So I know autoparsec has this handy function here for running parsers and feeding it data. So we've just been using straight parser, which takes a complete byte string. We could feed it ourselves, or we could use this. We might be able to use this handy parse with function, which takes some monadic action that produces byte strings and a parser. Okay, I've got one of those. We don't really need, we could just apply an empty byte string. We don't really need this parameter, but then it produces a result in our monad. All right, so this monadic action here could probably just be receive. And inside of our handler, and we get the result back, and then we should hopefully we'll be able to hope this can stream it through basically, so we don't end up parsing a really large command. So if you can imagine sending an array a command serialized in this format to this array of prims, and they're say uploading a 10 gigabyte movie to their key value store for some reason, into their Rosby database. We're gonna get that data eventually. What I don't want to have happen is to have the RTS allocate and continue to allocate and allocate and allocate and allocate until it's received all 2 gigabytes before handing it off to the data store, and then the data store has to put it into the data store there. So that would be no good. That would go against our design goals for this server, which is to really keep our usage of the RTS down to a bare minimum so that our users can predict how much memory it will use in addition to how much the store will use, so they can have a basically so we don't get out of memory killed is our ultimate goal. We don't want the out of memory killer killing Rosby. We want Rosby to be a good, happy citizen. Okay, so that's basically the next stage of parsing. We could probably just keep going. We should probably rename this module though. But anyways, I'm probably getting ahead of myself because I haven't committed this yet, so I'll just go ahead and do that. Yep. Add those two things. Commit them all. Oh, no, we don't want to commit. We want to lint first. Another thing that we, or I didn't get to last week, we got a little bit frustrated trying to write pre-commit hooks. I think I have a solution for that as well. So let's just hlint our stuff right now. No hints, look at that. Ah, bam. Writing perfect code with no lint errors right off the bat. It's a good feeling. I'm going to celebrate that later. Small victories, very important in this profession. Okay, we're going to add Source Rosby protocol parser. Really, this is like the serializer thing, but we'll rename the module later. Or maybe we should do that now. Should we do that now? Let's do that now. Let's unstage this file. Let's change that quickly. To serial. Yeah, let's do that. It's called serial. So this is the serialized format of our protocol. Makes sense. Okay, cool. Hopefully the benefit of moving over to WSL2, I've heard, is that it's almost as fast as running this stuff on native Linux, which is what I'm used to. Gosh, it would be nice to have a really, really fast widget that isn't slow. Okay, so we add the serial protocol. Let's give credit where credit is due. Our ESP. So that's where you can read a bit more about it. Or just great artists, you know, when they see a good idea, they steal it, right? That's what you do. But give credit, come on. Know your roots. Okay, so we added the module to parse the serialized format for our protocol based on ideas from our ESP. Added dependencies, add parsec, and word 8. Cool, I like it. Committed, pushed, boom. Okay, so we have like, I don't know, like 20 minutes left on the stream to go. Maybe we should just do a little housekeeping, or maybe we should keep going with more parsing. So we got the serial parser, so that's going to parse the serialized format of our protocol. What are we going to do when we need to actually parse the commands from the serialized format? So from our prim to our actual commands. Let's just go for it. Let's do it. Who cares? Live once. Rosby. Protocol. Command protocol. Okay. Okay, cool. So these are going to be, this is where we're actually going to parse out the actual commands that the user wants to like do. So they want to set a key, delete a key, and get a key. Those might be the only ones we support, maybe. Well, what I like about this model and doing things this way, separating the serialized version of your protocol and your actual commands and things like that, it's going to be pretty extensible. Right? And I think that kind of fits in with, I hope it's going to be extensible anyway. I might be wrong about this, but I have a feeling it's going to be extensible. So instead of like when our users like want to fork Rosby for maybe learning purposes and want to extend it with their own commands, or maybe they want to actually use Rosby for something, but it just needs just a few more special commands that they need for their application. They're not going to have to like mess with the serializer code too much. They could just add a new parser. They could extend this module here, extend the types from here, and still use the same serialized format over the wire, which will ease like writing their own clients and stuff for it as well. At least so goes the theory. All right, excuse me. All this talking makes you thirsty, boy. Okay, so we have a command. What is a command? We got this. We wanted to. We wanted to set get and delete. Right. Should probably have like new type wrappers for keys because I think there's going to be certain restrictions on keys when we're parsing them, like key size, for example. But set key byte string. So I'm going to set some data. I'm going to get a key, and you can delete a key. Those are like three higher level operations. Hopefully we can derive equal and show for these things as well. So let's just go create a new type key. Unkey. That's kind of a convention some people follow when you're doing this kind of like low-level type wrapping. Yeah, import data.byte string. Thank you. We're going to derive show for our key. I think that should do it just fine, because under the hood, as you recall, new types, just put a type name around some internal type. So Haskell's able to figure that out, and then that should be good. Okay. Our parser here, though, is not taking byte strings as input. It's taking prims. So I think auto parsec is going to be out of the picture here. We may end up having to write our own. Right, because what do I want? I want some kind of function. Like parse command. It's going to take a prim. It's actually going to take an array. But there might be other commands that maybe don't need it. We don't know. So it's going to take a prim. Ugh. And oof. Maybe we will have to write our own parser. That's okay. It looks kind of like this. And let's return either I'm just going to be lazy for now and put string, and either that or a command. Okay, so we don't have prim and scope. Should bloody well be. What are you talking about? It's not in scope. Try again. Maybe I gotta restart LSP here. Weird. Okay, LSP is throwing some weird errors here. Let's just make sure it's just LSP. No, it's absolutely not. Okay. Oh, okay. Yep, yep. That's totally on us. Shoot. Shouldn't have pushed that up so fast. Dirt. How did it... We ran HLint though. Did HLint not pick up on that? Weird. Okay, well, maybe that's something we should probably just double check that HLint can catch. If it can't, then maybe like another check we should do is like actually compile the code before we push. Or maybe not. Maybe that'll be annoying to do on every commit, but I don't know. So that looks better. Let's go add that commit. Gotta leave a little defense for myself here in the history. So my future self can take pity on my past self. Right, back to the command. That's better. You're happy now. I'm happy now. Okay, and now for our parser, we're going to need to implement a few types. Oh god, you know what? I really wish there was like maybe autoparsec was. It's a good library. It's nice and fast. Anyways, what I'm thinking here is that I wish there was kind of like a library that could be parameterized, like the part you could write parsers that could be parameterized over your input, so it doesn't have to be byte strings. It doesn't have to be fixed to byte strings like we're doing with our autoparsec. We could be you know, writing parsers like we are right now for off of lower level data types. We're going to need to implement. Oh, actually, we can't derive applicative, can we? No, we're going to have to implement applicative for our parser. We're going to have to implement functor and all that good stuff. Okay, let's get started. Can we just implement plain old functor? Yes, yes, yes. We're going to implement fmap. So we have a command parser. We have some f, sorry. And some command parser a. We're going to return a new command parser. We have some input. Apply f to a to that input. Is that right? A visible method. Okay, how about this? Either string or command, right. We can't just do that because we don't have that in scope. Okay, what do we have in scope, Haskell? Show us. Ah, haha. We have to produce either a string or a command. All we have is f, a, and input. Which is a prim. Yeah. Oh, maybe. No, that should be on the inside, right? What do you want me to produce here? Command parser, right? Yeah. So let's give you one. I don't know what to put in it though. I could just put a, but that wouldn't be right because we wouldn't be using f. And we have a hole here that's prim to thing, right? So this is how I do hole-driven development. I use it a lot. It's saved my bacon many times. Here. So in order to get, when you see that in your hole, an arrow, we're going to create a function that takes that prim in. And then we'll put a new hole on the right-hand side. Okay. Oh, sorry, lambda. The lambda abstraction. Okay, cool. So now we have to produce either a string. Okay, so either an error or a command. How does it? Oh, yeah, because run parser. Well, that should not be command then. A little too specific. It will be command, but we need a B. Okay, there we go. Either a string or B, friends. How can we get a B? What is an F? F goes from A to B. We have an A. Right? So, so A, we got an infinite type. Okay. That means you can't figure out what I'm trying to do. Right, so let's see. If you try to actually fmap over our implementation here right now with f, command parser, prim. We're not using prim at all. So we should probably use prim. I think actually we're running out of time here. I'm not gonna be able to finish this tonight. But anyways, next week we'll stash this. So we're gonna implement functor and applicative and go through all that rigmarole. Unless between now and next week I find that library it's not much bigger than attoparsec and we can write a parser over prims using it. Otherwise we're gonna have to continue on this journey and write it out ourselves, which isn't gonna be a whole lot of code, to be honest. It's pretty straightforward. Probably less than 100 lines you could do it in. Okay, so I'm gonna stash that. What's that? Okay, cool. Whatever. Have fun, Cabal. Yeah, just stage everything, please. Oh, wait, don't want to stage everything. Stash everything. Command parser. Yeah, I should probably push that up. Otherwise, we just broke master. Sorry, everybody. Saw it live. I've been programming for an extremely long time. I make mistakes constantly. It's fine. In fact, good software projects realize that mistakes are totally part of the business. It's how you do. Right? Hope is not a strategy. Okay, so that's been the stream. That's the stream, I think. Still got like 5 or 8 minutes. Maybe I'm gonna try. Maybe we should try that pre-hit commit hook thing again. I was doing some cheating to see how other people are doing it on GitHub. I think I found one I liked that would be easy for us, that doesn't require us to install frameworks and junk just to write a shell script. Oh, but it might not work on Windows, actually. It might work when we were doing it on the whatevers. Basically what I was looking for is page-lint. All right, so if you have make, people have been doing it in here, and then your pre-commit script would just call the make file. I think that's pretty straightforward. I don't think through the Windows developers out there, not sure I have make. Yeah. So okay, well maybe next week we'll get that going. Why don't we just write the little? Why don't we just run a little right now? Just make sure that we're good to go. Nah. We're gonna call it there. All right. Thanks everybody for coming out for the stream this week. This will be archived out to my YouTube channel and be available shortly after the stream ends. If you liked following along and you know other people who'd be interested in too, please tell them to come on out and see if they'd like to follow along as well. And don't forget to follow if you're on Twitch. That'll help you get reminders of when the next episode is. I'm doing these once a week, Tuesdays at 8:10 Eastern Standard Time. And yeah, we're finally making progress. So I'm excited. The parser is, the serializer is pretty easy to parse and set up. Once you get the command parsing going, that'll be great. And hooking it into the server and getting that going is going to be really fun. So yeah, hopefully we'll see you again next week. Take it easy, fam. Peace out.